Minutes worth of this. This is notes 8, derivative of functions. We're finally going to see the word derivative. All right, we're going to go slow. So it says in section 2.4, well, we're not using a textbook, so you don't know what section we're in. We defined the slope of a curve at the point where x equals a to b, and we said that was your tangent slope. Tangent slope. When it exists, the limit is called the derivative of f at a. So there it is. In this section, we investigate the derivative of the function derived from f by considering the limit at each point of the domain of f. All that means is we're going to find an expression that describes my tangent slope. That's what it means by we're going to derivative of the function. So it has an x in it. That's all it means. Cool or not cool? So they tell me that this is my derivative, and here's my notation. So that's the notation for derivative. And then it says here, the domain of f prime, the set of points in the domain of f for which the limit exists may be smaller than the domain of f. If f prime exists, we say that f as a derivative is differentiable at x. A function that is differentiable at every point of its domain is a differentiable function. Okay. All that means is if you have a curve and you can get a tangent line, you're differentiable. That's all it means. So if I have a curve like this, notice that at that corner, how am I going to make a tangent line? How is it going to look? Or you know what? Let me do a better one because you guys are probably, we're not experienced yet. Okay, so this is like a corner. If I approach from the left-hand side, my tangent slope would look like that. If I approach from the right-hand side, right at that blue point, my tangent slope will look like that. I can't agree at that specific point. So that one is not differentiable at that point. Does that make sense? So to be differentiable, you got to have a nice smooth curve. If you can create a tangent line, you're differentiable, for the exception of vertical tangents. So notice at this point, are you differentiable? Yeah, I got a tangent line right there. At this point, are you differentiable? Yeah, I got a tangent line right there. This point, are you differentiable? Yeah, I got a tangent line right there. Anywhere that you can draw a tangent line, you're differentiable, for the exception of vertical tangents, because a vertical line does not have a slope. It's undefined slope. So, and remember, the derivative literally means tangent slope. Cool or not cool? Okay, so notice what this says. It says differentiate, that is, find the derivative of f of x equals 3x squared. Once you find the derivative, find f prime of 1, f prime of 2, f prime of 3. Okay, you guys ready for our first derivative? Here we go. I'm going to write f prime of x equals limit as h approaches 0 of f of x plus h minus f of x all over h. So this is what it means by finding an expression for this derivative here. It's going to be a function. Are we okay so far? I know that f of x is 3x squared, so on the side I'm going to go f of x is 3x squared, and then I'm going to write f of x plus h is 3 parenthesis x plus h close it squared. Do we have any questions on how I got that? Please ask. Abdul Kareem, Wasan, do we have any questions? That was a bad joke. I shouldn't have done that. You guys just told me that you get triggered with your first name, and here I am, like, on purpose trying to trigger you. So. You never knew I call you guys by your last name? I call you by your last name all the time. Oh. So you? Oh, she got triggered. Her and Angie got triggered a little while ago. You should have seen them. They were going like hardcore. Kendra? Man, you guys are going to make me feel like I'm a weirdo. All right. I'm sorry, Alvarez. I won't do that. I mean, I feel like I'm more of a Chad than an Omar. But, all right. All right, guys. Sorry for distracting you guys. I apologize, miss. Don't hate me. All right. Here we go, guys. Here we go. So I'm going to go ahead and expand it. So I'm going to go 3 parentheses x times x is x squared, and then x times h is xh, where you're going to have how many of those? So I'm going to write 2xh, and then h times h, and then go ahead and distribute that 3. So 3x squared plus 6xh plus 3h squared. Cool or not cool? So then I come back and I write f prime of x is equal to limit as h approaches 0, and I write the expression of f of x plus h. So I'm going to go 3x squared plus 6xh plus 3h squared minus 3x squared. All this is over h. You are done with calculus. The rest is just algebra. What can I zero out? The 3x squared, zero out first. And then can I factor out an h? I can. So let me write a new line. F prime of x is equal to limit as h approaches 0. Here's my h factored out, and I have 6x plus 3 all over h. You don't have to do that. If you just want to just cancel, that's fine, but I want to show the work here. What cancels out? The h's. And now I can do direct substitution. Well, actually, there should have been another h in there, right? Yeah, 3h. Now I can do direct substitution. So that h is approaching 0, so I just have 6x. You can write 6x plus 3 times 0 if you want, but 3 times 0 or anything times 0 is going to be 0. So I just have what? 6x. So then we say f prime of x is equal to 6x. And now let's find these f prime of 1, f prime of 2, f prime of 3. So I'm going to write f prime of 1 is equal to 6 times 1, which is 6. So my tangent slope at 1 is 6. F prime of 2, the tangent of what? The tangent of 3x squared at x equals 1. So f prime of 2, 6 times 2 is 12. So my tangent slope at x equals 2 for the function 3x squared would be 12. And I guess where do I fit it? Right here on the side. F prime of 3 equals 6 times 3, which equals 18. Your tangent slope at x equals 3 would have been 18. How do we feel? Nothing crazy, right? Okay. Let's go to the next one. I messed up all of that. Oh, that's fine. This is the alternate definition. So notice it says, this is what I tried to teach you guys last time, but you guys were like, no, just teach me one. This is the alternate definition of derivative at a point, and it's already evaluating the point for you. So it says, find the derivative in example 1 again, this time using the alternate definition. All right, you guys ready? All right, well, technically it says f prime of a, so I guess I have to put a number already. So f prime of 1, so I know, but I think I mistyped it because I wrote the definition as f prime of a. So I think I just mistyped it. Find the derivative in example 1 again. Okay, well, no, I didn't just mistype it. You could say find the derivative f prime of 1, f prime of 2, and f prime of 3. You're not going to get an expression of this because you're setting x equal to a point already. You know what I mean? So you're not going to get an expression. You're just going to get a number right off the bat. F prime of 1, limit as x approaches 1, according to my definition there. F of x, which is 3x squared, minus f of a. If I plug in a 1 in there, what's 3 times 1 squared? 3 all over x minus 3. Oh, x minus 1, sorry. The a is 1. I can't just make up any number I want. Okay, are we okay so far? Yeah, in case you don't know what I just did there, guys, I found what f of a was. F of 1 was 3 times 1 squared, which is 3. And then this one's f of x squared, which is just 3x squared. F of x squared. F of x, which is just 3x squared. Are we okay so far? Yeah, of course you do, because you already know limits. Limit as x approaches 1. What am I going to factor out in the numerator? 3, and you have x squared minus 1 over x minus 1. Can I do direct substitution? Not yet. Correct. You can't do direct substitution because you get a 0 in the denominator. So limit as x approaches 1, 3, and then the numerator is the difference of squares. So x plus 1, x minus 1 over x minus 1. What's going to cancel out? The x minus 1s cancel out. That's a common factor. Now can I do direct substitution? Yes. What is 3 and then 1 plus 1? 1 plus 1 is So what's 3 times 2? So here it is. So here's my answer. F prime of 1 is just 6. Is that what we got last time? Okay. I'm going to change my color to show F prime of 2. So here we go. And I'm going to go slow. F prime of 2 is equal to limit as x approaches 2. And it's f of x, which is 3x squared minus f of 2. Now, if I plug in a 2 into f of x, I'll write right here f of x, 3x squared. If I plug in a 2 into my f of x, if I plug in a 2 right there, what is 2 squared? And 4 times 3? So I write 12 over x minus 2. We are done with the calculus. All we're doing now is algebra. Limit as x approaches 2. I'm going to factor out what in the numerator? 3, and you're going to get x squared minus 4, and on the bottom you have an x minus 2. You still can't do direct sub, but the numerator is the difference of, so here it is, limit. So try and write kind of small so you can fit it all in there. As x approaches 2, 3, parenthesis, x minus 2, open, close, x plus 2, close, and then x minus 2. What can I delete? The x minus 2's. And now can I do direct substitution? Yes. So now here's what you get. What is 2 plus 2? And 4 times 3? So I'm going to write f prime of 2 is nothing more than 12. Was that the answer I got last time? Yes, it is. Let's do one more. I know that I have very little room, but I'm going to change my color. I'm going to use purple. I'm going to try to fit it all. Well, I got some space here, I guess, technically. So I'm going to try and fit it all there. So here we go. F prime of 3 is equal to limit as x approaches 3 of 3x squared minus, so let's see what this 3x squared is when I plug in a 3. What's 3 squared? 9. And 9 times 3? So 27 over x minus 3. So let's see. I still keep writing the word limit because I haven't inserted anything. What can I factor out in the numerator? 3. And because I'm running out of space, I'm going to go ahead. I'm going to have x squared minus 9, but that's the same thing as. So I'm just going to go ahead and do that. X minus 3, x plus 3, all over x minus 3. What cancels out? Now that I canceled out the x minus 3, can I do direct sub? 3 plus 3 is, and 6 times 3? So look what I got. F prime of 3 is just 18. Is that what I got earlier? There you go. Good job, guys. How do we feel? Alum from last year. Yeah, Max. Okay. All right, guys, focus. All right, here we go. Notation. You guys ready? All these mean first derivative or one derivative. First derivative. First derivative. So how do you pronounce it? Y prime. Let's put a little prime on it. This is dy dx, or the derivative of y with respect to x. This is kind of like, okay, before you guys, I don't want you guys to turn into a robot. Notice this dy dx. This is like, it's not, well, I guess let me change the font. It's like change in y over change in x. We just start using, the d really stands for difference, differentiable. We use dy's and dx's when we're taking really small changes in x's and changes in y's. Infinitesimals is what they call it. Practically zero. So we're talking about very small changes in y, 0.000000001, over very small changes in x, 0.000, like very small changes. df dx, this comes from really, these two mean the same thing. If I go d dx of function f, they just distribute it. So d, and I've seen this notation as well. They all mean the same thing, guys, just derivatives. We use change in y over change in x when we're not doing calculus, when we're just a change in quantities, and we're using dy over dx when we're using calculus, differentials, infinitesimals. Cool or not cool? Anything crazy? Okay. So notice. Don't worry, we're gonna stop. Let's see, where do we stop? We'll stop at example 3. And yeah, we'll stop at example 3. Okay. It says find f prime of x for the following functions below. You guys ready? So they're asking you to find a derivative. So how do you pronounce this? I just said it right now. F prime of x, or f prime. You can also say first derivative. All right, so here we go. All we know right now is our little formula. So I'm going to write f prime of x equals limit as h approaches 0 of f of x plus h minus f of x all over h. Where's Abdi Kareem? She got offended. I think she got offended that I called her by her first name. Yeah, don't be leaving my classroom out of this just because like I'm out of here. Okay, sorry. I do feel sorry. All right, here we go. You guys ready? F of x is square root of x. So I need f of x plus h, which is just the square root of x plus h. So I'm going to write equals limit as h approaches 0, square root of x plus h minus square root of x all over h. Are we still okay? Don't freak out. We're done with calculus. Now it's just algebra. I look at it and I'm like, well, I can't do direct substitution because I get a 0 on the bottom. So I'm obviously going to have to do something with the numerator. What do you think I should do with the numerator? Multiply by the conjugate. So I go square root of x plus h and then put a plus symbol outside that square root of x, over square root of x plus h plus square root of x. Are we okay with that step right there? Okay. So then here we go. Here's what I have. I'm going to put an equal sign, and I'm going to go ahead and this is like a minus b times a plus b. So that's just the difference of squares, so I can just do those. So I'm going to write limit as h approaches 0, and then square root of x plus h times square root of x plus h is just going to be x plus h. And then square root of x times square root of x is just going to be x, but you have a minus in the front because negative times a positive is a negative, so put minus x all over, and then put h times square root of x plus h, and then plus square root of x. Are we okay so far? Okay, what am I going to zero out first? The x's. Yeah, you got to zero out the x's, and now that I've zeroed out the x's, what can I cancel out? The h's. Correct. Equals limit as h approaches 0. You have a 1 in the numerator over square root of x plus h plus square root of x. Can I do direct substitution now? What do you guys think? Yes. H is 0, so this is 1 over square root of x plus square root of x. Well, square root of x plus square root of x is how many square root of x's? So 1 over 2 square root of x. I come back and I write a nice clean sentence. I'm just going to write f prime of x is nothing more than 1 over 2 square root of x. Make sure that the 2 square root of x is in the denominator. Are we all right, Chad? I can't call her by her first name. She gets rowdy.
Chad.
I'm sorry, miss. I'll stop because I'm reaching borderline bully now. Yes, miss. Oh, h is approaching 0, so I can do direct substitution. So x plus 0 is just x. You know what I mean?
What's her name?
No, I mean, I don't want to, because then she's going to remember me as a bully forever, miss. Oh, I like that. All right.
You know who started that?
Who?
Milena in like 6th grade.
So she was a bully initially.
No, it wasn't a bully. She was just like, oh my gosh, your name sounds like phalanges.
Phalanges. Okay, I'll stop. All right, here we go. You guys ready for the next one? Yeah, we're all right. So so I'm gonna write. So I need f of x and I need f of x plus h. I already have f of x. I'm gonna put semicolon. F of x plus h is nothing more than 1 over x plus h. Are we okay? So here we go. I'm gonna write f prime of x is equal to limit as h approaches 0, and I need f of x plus h. So I write 1 over x plus h minus 1 over x, and all this is over h. So catch up to there. That's the limit definition. F of x plus h minus f of x all over h. The derivative definition. Yes. Are we okay so far, guys? You're done with calculus. I need to do algebra. I'm going to multiply the right term in my numerator by x plus h over x plus h. I'm going to multiply the left term in my numerator by x over x. Are we okay? When I do that, I have limit as h approaches 0, x over x parenthesis x plus h minus x plus h over x parenthesis x plus h. And I wasn't going to show that, but I want to show all the details right now. So there it is, me showing all the details, all the deeds. Ask me, Estrada, what happened? You okay, Estrada?
Oh yeah, I was
Okay.
just.
Okay, no, you're good, miss.
You're making this away from my tiny brain.
Miss, you have a big brain. All right, are we okay? All right, here we go. I'm gonna combine like terms, guys, or I guess I'm gonna make it one fraction. X minus, I'm gonna distribute this, minus x minus h. So x minus h. Are we okay with that? And then x parenthesis x plus h, and then I'm gonna bring this h up. Are we okay with that? Okay. What's going to zero out first? The x's. Now, once the x's zero out, what can I cancel out? The h's. And now, oh, I didn't even write the word limit. Why didn't you tell me, guys?
Well, you're the
What was that? I missed. I have to write the word limit because I haven't evaluated anything.
But then you left negative 1 on top.
Yes. All right, now, because it says the word limit there, limit, what is h approaching? 0. So now I can do direct substitution. And I have negative 1 over, what's x times x? So I can write a line. I can write f prime of x is equal to 1 over negative 1 over x squared.
What happened to the
H is approaching 0, yeah. No, those are good questions. Keep asking them, miss. You got it again. Is that a yes? Oh, is that a no? Again, you got it? Okay. All right. One more, well, actually two more, but we're C and D. So we're going to stop after this example. No, we said 20 minutes, so I feel like we're getting close to that 20-minute mark. Maybe we passed it. All right, here we go. I'm going to find the derivative of 5x squared. You guys ready?
Wait, give me 1 second.
Okay.
Okay, good.
I need f of x plus h. 5 parenthesis x plus h, close it, squared, equals 5 parenthesis, what is x times x? X squared, and then plus x times h is xh. We're going to have, so 2xh plus h times h. H squared, distribute the 5. So 5x squared plus 10xh plus 5h squared. Are we ready? Here we go. F prime of x is equal to limit as h approaches what? 0. And then I write this expression out. 5x squared plus 10xh plus 5h squared minus, what's f of x? And all this is over h. What do I zero out first? So zero them out. Now can I factor out an h? So I'm going to write a new line. You don't have to. If you just want to just cancel, go for it. Limit as h approaches 0. Here's me factoring out that h. 10x plus 5h. All this is over h. Now what can I cancel out? The h's cancel out. What is h approaching? 0. So direct substitution. 5 times 0 is 0. So all I have is... So the derivative, or f prime of x, is nothing more than 10x. Are we okay? Okay. Last one here, and then we'll call it a day for now, and then we'll do the rest tomorrow. All right, here we go. I need f of x plus h, so on the side, I'm going to put a semicolon. I'm going to write f of x plus h equals 7, parenthesis, x plus h, close it, plus 5. Distribute the 7. 7x plus 7h plus 5.
That threw me off guard when you said
Oh, did you get triggered with the 5?
no, I didn't.
Everyone's getting triggered. Who wants to get triggered next?
It sounds like you're triggered.
I know.
You might want to cut that out.
Nah, I'm going to leave it. And I'm kidding. You guys know I'm kidding, right? Yeah, I want to make sure. I don't want you guys to leave home and like, man, Chavez really got hurt today. You know I'm kidding 100%, right? Okay. Abdul Kareem, you know I'm kidding, right? Alvarez, you know I'm giving you a hard time, right? Okay. You feel safe, right? You don't. Okay. All right. Here we go, guys. Here we go. Sorry. F prime of x equals limit as h approaches 0, and I'm going to write the expression of f of x plus h. So I'm going to write 7x plus 7h plus 5 minus parentheses 7x plus 5. If you want to distribute that negative, go ahead. All over h. Are we okay so far? Okay, I'm going to do another line. F prime of x equals limit as h approaches 0. I'm just going to distribute it right here, guys. 7x plus 7h plus 5 minus 7x minus 5 all over h. Are we okay? Okay, here we go. Ready to cancel some stuff out, or zero some stuff out first. All right, what zeros out?
7x.
The 7x and the 5. Now that I zeroed out those, what can I cancel? One of the h's. What do I get? 7. So f prime of x is nothing more than 7. Now, before we continue, because that's it for today, but hold on, hold your horses. Are you shocked that we got 7? No. Remember that this stands for instantaneous rate of change, or slope of the tangent line. Notice this is a linear line. What is the slope of this linear line always? It's always 7, no matter what. Always. Do we see that, guys? So if you have a linear line, you do not have to do all this mumbo jumbo. If you have a linear line, just whatever that slope is, write f prime of x equals that number. Does that make sense, guys? Yeah, write that down.
Somebody's a coach on that one.
Oh, sorry. Do we understand that, guys? All right, guys, I'm going to cut it short right here. We will record the rest of this on, and just let's get started with the next one, guys, here. So this is just practice now. So I know that we said the derivative of a linear line is just going to be 3, but I just want to make sure that we're going through the motions so we know how to do these for a fact. So it wants me to find f prime of x. So I need f of x plus h, which is 3 parentheses x plus h, close it, minus 1. Distribute the 3 like so. 3x plus 3h minus 1. So here we go. I write f prime of x is equal to limit as h approaches 0. And I'm going to write 3x plus 3h minus 1. And I'm going to subtract f of x, which is 3x minus 1, all over h. So I'm hoping that the more you do this, the closer it becomes to automatic. You want to get to a point where you're not even thinking, because you're just like, oh yeah, I've done so many. And you're just going really fast. You know what I mean, guys? When you distribute, what'd you say? Oh, I haven't, okay, yeah. No, you're good. You're good. 3x plus 3h minus 1 minus 3x plus 1 over h. You should always be able to zero out your f of x function. So notice that the 3x's cancel out. The positive one and negative one cancel out. And now, or zero out, I should be saying. And now what cancels out? The h's, and this one just gives me. And that is not a surprise because this is a linear line. So the slope is always 3. So remember what you found. This is an expression for the instantaneous rate of change. The instantaneous rate of change is always 3 because I just have a linear line. Yay or nay? Okay, nothing crazy. All right, so this one is going to start looking maybe a little crazy because of all the x's and all that. So I'm going to write it right here, guys. I'm going to go slow. F of x plus h, that's what I need. So parenthesis, x plus h close it squared, minus 2, parenthesis, x plus h plus 3. I haven't done anything crazy, right? And then I'm still just expanding it, so I'm writing over here. When I expand the x plus h squared, what's x times x? X squared plus, what's x times h? Yeah, it's xh, but you have two of them, so 2xh. And then h times h. And then I'm going to distribute that 2. So minus 2x minus 2h. And then plus 3. Are we still okay? All right, now I'm going to write the limit statement. So I'm going to write f prime of x is equal to limit as h approaches 0 and all this mambo jumbo. X squared plus 2xh plus h squared minus 2x minus 2h plus 3 minus, and I'm going to go ahead and distribute the negative already, guys. So I'll slow down. Minus f of x. So I'm going to distribute the negative already. Child, what are you talking about distribute the negative? It's minus all this. So I'm distributing the negative to all three of those terms. So minus x squared. Negative times the negative is so positive 2x and then minus 3. And all this better be over h. So catch up to there. Now I'm going to start zeroing out stuff. Your f of x should always be deleted. You should always be able to cancel it out. If you can't, something is wrong somewhere. So everything on the right-hand side, I should be able to delete it. Do I have a positive x squared? So the x squares can't zero out. Do I have a negative 2x? So the 2x's zero out. Do I have a positive 3? You should always be able to zero out your f of x. If you can't, something's up somewhere. Next, I notice that every term, there's 3 terms left, has an h on it. You can cancel it out immediately if you know what you're doing, but I would caution you. It's probably better to go slow in the beginning, and then once you got the hang of it, then you can just go scratch out, scratch out, scratch out. But at the beginning, go ahead and factor out the h so we know what we're doing. Limit as h approaches 0. Here's my h factored out. 2x plus h minus 2. All this is over h. And the reason why we can cancel out the h is because in the numerator I have a product, and I have a product that being divided, so multiply and divide are inverse operations, so we can just cancel those h's like that. Does that make sense, guys? So now that I've done that, can I make h approach 0? Yes, h is approaching 0, so this is just 2x minus 2. So let me write one last statement. My derivative, f prime of x, is just 2x minus 2. Bless you. Salud. Bless you squared. Bless you cube. Bless you fourth power. Bless you fifth power.
What the heck?
The record so far that I can remember is to the 12th.
What?
Yeah, someone sneezed 12 times in a row, and I never forgot it. I was like, oh, 12. So she has the 8 times. Well, so the most someone's ever sneezed, at least while I've been here, has been 12 times in this room. Someone went shoot consecutively. Yeah.
And did you just
So.
keep going like?
Yeah, just like that. She said that she could breathe perfectly afterwards. She was like, "Oh, everything's so clear now." Like, well, yeah, after 12 sneezes. All right, here we go.
It's like your nails have been clear.
Yeah. All right, here we go, guys. Here we go. So on this one, remember the algebra is what's going to hold you guys back, not the calculus. So I'm going to write f of x plus h, and that equals 1 over parenthesis x plus h, close it squared, equals 1 over, and I'm just going to expand the x plus h, guys. X times x, x squared, plus, and then x times h, that's xh we're going to have. So 2xh plus, what's h times h? All right, so here we go. I write limit as h approaches 0 of 1 over x squared plus 2xh plus h squared minus 1 over x squared, all this over h. I can't do anything at the moment. You can't do direct subs or anything. So we have to revert back to algebra. And so you're like, well, I guess the only thing I can do is find a common denominator. So I find a different colored pencil. I'm going to multiply this by x squared plus 2xh plus h squared over the same thing. X squared plus 2xh plus h squared. And I'm going to multiply this one on the left by x squared over x squared. I would not bother actually distributing the denominators because, you know, I mean, I guess you could, but so I'm going to write it like this. Limit as h approaches 0. Of course, in the numerator, I'm just going to write x squared. But in the bottom, I'm going to write it like this. I put x squared, parenthesis, x squared plus 2xh plus h squared. You can if you want to distribute that, but I don't. Minus, and then I write the same thing in the numerator. X squared plus 2xh plus h squared. That's an h there. Over x squared, parenthesis, x squared plus 2xh plus h squared. Close it. And all this is still over h. I'm going slow. And don't worry, I'm about to slow down. I'm going to put it all together now. Put parentheses if it helps, because you got to distribute that negative there. Does that make sense? So here we go. I'm just going to write one limit statement. It's going to be a long one. Limit as h approaches 0. Here's my numerator. X squared minus x squared minus 2xh. I'm distributing the negative. Minus h squared over, and I guess I'll write this denominator first and then I'll bring up the h. X squared, parenthesis, x squared plus 2xh plus h squared, close it, and bring up the h. Keep change flip. The h goes right there next to it. Are we okay? Okay. I'm going to zero out what I can zero out. Let's see. The x squared zero out. And can I factor out an h? So I'm going to go ahead and I think we might be good enough that we can just do this. There's me factoring out an h, so I just canceled them. I don't have enough space to do it, so I just did it like that. And now what is h approaching? So this h is approaching 0. So my output is just, oh, and then okay, not yet. I got to cancel something else out. I canceled the h, but I also got to cancel one of the x's. So cancel that with one of those. Yeah, this x in the top, the 2x. Cancel that x with one of the squares. So I'll write it here on the side. So I have this, 2x over x squared. So you're going to cancel one of those with one of those. So you're going to have 2 over x like that. So equals, now it's not a 2 over x, it's a what? Negative 2 over x. Does that make sense? So I'm going to put a semicolon. So that means f prime of x, that's derivative, is equal to negative 2 over x. Oh, you're right. I just skipped it. Good thing you guys told me. Man, I'm so dumb. All right, parenthesis. Hold on. H is approaching 0, so that means this approaches 0 and this approaches 0 because I have the h on it, but this does not. What does x times x squared equal? Yeah. So I'll go ahead and write it like this, and then I'll write negative 2 over x cubed. And that's the right answer. Sorry, guys. Tisk. Here we go. Oh, what happened? Ask me.
Is it still, you still write it like f prime of x?
Oh, yes. I still want to do that. F prime of x equals negative 2 over x cubed. Yeah, you got to ask me, miss. I forget sometimes. especially when I make mistakes. When it rains, it pours. Yeah, good. Let's see what I. Hey, what's going on? This is Travis. Oh, I thought I submitted it. Oh, I didn't push the OK button. Because I told them that I did the attendance, so it couldn't have been attendance, but look, I'm showing them my monitor right now. I just didn't push the OK button, but okay, I'm on it. Okay.
It's like, oh, I guess when I submitted it.
I did submit it. Well, almost. Now it's submitted.
You'll get it next time.
All right, here we go. So this says find the derivative at the given value of a utilizing the specific definition. So they want me to do the definition over and over again. So right now, all we're doing is using this definition over and over again until we're really good at finding tangent slope. Cool? All right, so here we go. So this wants me f prime of 2. So I'm going to write f prime of 2 equals limit as h approaches 0. And it says f of a plus h. So that means 1 over 2 plus h. Have I confused anyone?
Yes.
Okay. I'm going to come here to the top. F of 2 plus h is equal to 1 over 2 plus h. So wherever there's an x, I put in the expression, right? Yeah, a is 2. It says a there. So I'm plugging in a 2 in there. Minus, it says f of a, so that means f of 2. So if I plug in a 2 for x, that's minus what? 1/2. Yeah, 1 over 2. And all this is over h. You are done with calculus. The rest is what? Algebra. So I take my little marker here, or digitizer. I'm going to multiply this one by 2 plus h over 2 plus h. I'm going to multiply this one by 2 over 2. So when I do that, let's see what I get. Equals limit as h approaches 0 of 2 over 2 times 2 plus h. I'm not going to distribute it. I know I could, but I'm not going to. And then 2 plus h here over 2 parentheses 2 plus h. On all this is still over h. Do I still got space? Yeah, I still got space. So now I'm going to put it all together now, guys. Limit as h approaches 0, 2 minus 2 minus h. Have I confused anyone with the minus 2 minus h? Yes? Okay. All I did was distribute this negative like so. Yeah, you got to stop me, guys. Are we clear now? Okay. All this is over 2 parentheses 2 plus h. Close it. And I'm going to bring up this h. All right. And I'm going to go slow. I'll wait for you guys. So let's see what zeroes out. What zeroes out first? The 2's. Now that I've canceled out the 2's, can I cancel one of the h's out? Yes. Remember, you still have a negative 1 on the top. What is this h approaching? 0. So what do I have? I have negative 1 over, what is 2 times 2? 4. So that's my tangent slope at 2, or f prime of 2. F prime of 2 equals negative 1/4. How do we feel? Okay. I'm going to take a different color to utilize that I'm doing a different letter here, letter B. This one wants me to find the same thing, but it wants me to use the alternate definition. It's actually the same definition if you think about it. It's still doing y2 minus y1 over x2 minus x1, where your h is like x minus a, and yeah, since x is approaching a, that means h is approaching 0, right? It's just doing the y2 minus y1 over x2 minus x1, and x is approaching a instead of h approaching 0. So check it out. I'm going to write f prime of 2 equals limit as x approaches 2, and then f of x, which is 1 over x, minus f of a, which is minus 1/2, all over x minus 2. You're done with calculus. Everything else is algebra. I take my little denominator here, or my little pen here. I'm going to multiply this sucker by x over x. I'm going to multiply this sucker by 2 over 2. Are we okay so far? So then I'm going to write equals limit as x approaches 2. And I'm going to have 2 over 2x minus x over 2x. And all this is over x minus 2. Now I'm going to write the next line. I'm going to write it like this. Limit as x approaches 2. And I'm going to write 2 minus x over Let's see. I'm going to put the 2x first, and then parenthesis x minus 2. Child, there's nothing you can do to cancel out. Okay, when you get to here, I need you to observe that the 2 in the numerator is positive and the x is negative. And observe in the bottom that the x, this one right here that I'm underlining, that the x is positive and the 2 is negative. So all that happened there was the switch in polarities. So you recognize, child, what do you recognize? You recognize that if you factor out a negative in the numerator, it's going to turn to that expression on the bottom. So here I am. I'm going to write limit. Let's see if I can fit it. As x approaches 2. Oh, just throw it in that basket right there. You see it? Where it doesn't matter. I haven't done anything yet. I was about to. Put a negative in the front. Keep, change, flip. A over B divided by C over D is equal to A over B times D over C. So A, D over B, C. So that's all I did. I keep, change, flipped. I'll write it. And then, all right, so I did this. 2 minus x over 2x over x minus 2. So that's like x minus 2 over 1. So I did 2 minus x over 2x times 1 over x minus 2. So notice 2 minus x over 2x parenthesis x minus 2. Keep, change, flip again. Cool or not cool? All right, here we go. There's my negative factored out. X minus 2 over 2x, x minus 2. Now, what factors cancel out? Bam, bam. Now, I can do direct substitution because now I'm not getting a 0 in the denominator anymore. Do we see that, guys? So, now I can just go equals. I'm doing direct substitution. There's still a negative in the top, so negative 1 over, what's 2 times 2? 4. So, semicolon, f prime of 2 equals negative 1/4. Did we get the same answer? So in the future, you will choose which one you want to use. You also have to recognize when, like, what's a derivative. You'll see what I mean. What's up? Ask me, Flores. For sure? No, it's because you should. I wish you guys could see it through my lens. Here's what I'm looking. I'm looking, and you're and then I'm looking at you, and you're like, no, you gotta hit me. Okay. Okay, good. All right, so we already know we have a linear expression here, guys. We already know that we're gonna get 3, but I want you to go through the motion so you can practice. Does that make sense? But we already know it's a linear line. I already know that my derivative is gonna be 3. Cool or not cool? All right, so let's see if we can figure this out. F prime of negative 1 is equal to limit as h approaches 0. And this says f of negative 1 plus h. So I'm just going to plug in the negative 1 plus h wherever there's an x. 3 parenthesis negative 1 plus h, close it, minus 12. Is everyone okay with that? Minus giant parenthesis. And I think we can do this, just type in one number. 3 times negative 1 is negative 3. And negative 3 minus 12 is negative what? So I'm going to put negative 15. Does everyone see how I got that number? From right here. 3 times negative 1 minus 12. No, you're good, miss. You're good. All this is over what? H. All right, I'm going to go ahead and distribute. I know that in the past, I would have just done this on the side. But right now, I'm just going right into it. There's a reason for that. Everything's by design. So I'm going to distribute that. Limit is because you're about to have a UH quiz, and the UH quizzes don't simplify it. They just leave it in. You'll see what I mean. I think I put an example in here. So negative 3 minus, oh no, not minus, plus 3h. Are we still okay? Minus 12 plus 15. All this over h, and I guess I could have. Well, no big deal. I'm going to make another one. So limit as h approaches 0. So negative 3 minus 12, that's a negative 15 plus 3h plus 15 all over h. So here's what I'm going to do. I'm going to use this one to simplify. What zeroes out? The 15th. Now that I've zeroed out the 15th, what else cancels out? The h's. What am I left with? 3. So f prime of negative 1 is just, are you surprised by that? No, that's what it's supposed to be. It's a linear line. Okay, I'm going to choose a different colored pencil. So if you have colored pencils or a different pen or different ink, this is the time so you can tell which one's which. All right, I'm going to use the alternate. If I use the alternate, I better be getting the same. Hey, no yawning. That's a demerit, miss. Yeah, the next one's going to be 3 demerits and a phone call. YouTube, I don't actually do that, YouTube. All right, here we go. F prime of negative 1 equals limit as x approaches negative 1 of f of x, which is 3x minus 12 minus f of negative 1, which we said was negative 15. Notice I put it in parentheses, minus a negative, all over x minus a negative 1, so that's going to turn into a plus. Are we still okay? All right, so let's go ahead and figure this out. F prime of negative 1 equals limit as x approaches negative 1. And I'm going to have 3x, and so negative 12 plus 15, that is a plus 3 over x plus 1. Have I confused anyone? Espinosa, are we okay? For sure. What did I do? Which, yeah, I did, but what exactly did I do to simplify? I just added what? Okay, just checking, miss, just checking, because you yawned earlier, so I gotta make sure, I gotta keep you on your toes, miss. All right, I'm not bullying anyone, am I? Okay. All right, what can I factor out of the numerator? If I factor out the 3, I have what can I cancel out now? Are you shocked that you got a 3? No, that's what you should be getting. That's expected. They're both the same to me, so I don't have a favorite one way or another. But if you guys, okay, this is just me taking a guess, because I know more or less how you guys think. If you guys had a favorite, I would say it's probably the one on the left.
I think it's more fun. I like the left one, right? I like crossing the stuff out. It's like a little game.
I know why you like the left one, because you have more experience with it. That's the one. If we would have, I bet you anything. I'm gonna try it next year. Next year, I'm gonna do this one first, and I'm just gonna talk about that one, and I'm gonna ask the class of 2025, like, all right, which one do you like first? Better this one, and they're gonna tell me I like that one, and I'm gonna be like, last year the class of 2024 did the other one. It's because
I feel more
we'll
like
see.
a mathematician because I'm like writing out a bunch of numbers.
You should tell them that we like the F of X.
We'll see.
H, and tell them that like we like that one better because we thought it was harder and more challenging.
It's all the same. All right, guys, let's continue. Here we go. You guys ready? Yeah. So this one's going to be, well, I wouldn't call it necessarily tough because it's a square root, but it's just more algebraic. So here we go. F prime of 3 equals limit as h approaches 0. So this says f of a plus h, so this is my f of x. So square root of 3 plus h plus 1, don't worry, we'll simplify it in a little bit, minus, this says f of a, so f of 3. So 3 plus 1 is 4, and what's the square root of 4? 2, all over h. Are we okay? All right, so simplifying it a little more, so I'm going to write equals limit as h approaches 0, square root, and then 3 plus 1 is 4, so I'm going to write 4 plus h, and then outside that square root, I'm going to put minus 2 over h. You're looking at it, and you're like, man, what am I going to do with that? Let me make it a little, because I made it really long here. So square root, and then minus 2 there. All right. I look at it, there's nothing you can do with it like the way it is right now. You can't do direct substitution. So obviously we're going to have to do something with the numerator. So I'm going to be multiplying the numerator and denominator by the conjugate. And the reason why we're doing that is because it's like the difference of squares and, well, you're multiplying by 1, so you haven't changed anything. Are we okay with that? All right, when we do that, here's what we get. Limit as h approaches 0. Square root times square root. Do the square roots go away? 4 plus h, and then negative 2 times positive 2. That is going to be minus 4 all over, and in the bottom you're going to have h parentheses square root of 4 plus h plus 2. Don't distribute. Leave it alone. What's going to zero out first? The fourth. Now that I've zeroed out the 4s, what can I cancel out? The h's. Now can I do direct substitution? Yes, this h here inside is going to approach 0. So you get the square root of 4. What's the square root of 4? So I have 1 over 2 plus 2, which is just 1/4. All right, let's do it the other way. So I'm going to change a different color. I'm going to use like light purple. So here we go. Is that what that color is? Lavender, light purple? F prime of 3 equals limit as x approaches what? 3. And then it says f of x, so that means the function itself, x plus 1 minus f of 3. So if I plug in a 3, 3 plus 1 is 4, and the square root of 4 is 2, all over x minus 3. Because I'm doing f prime of 3, so it's x minus 8. Are we still okay? All right, next. I look at it and I'm like, well, I can't do anything there. So that means I got to multiply by the, of which one? Of the numerator, because that's the one that's complicated. So square root, what do you mean complicated? Well, it has a square root in it. And we want to get rid of it. Square root of x plus 1 plus 2 over square root of x plus 1 plus 2. When you do that, let's see what we get. Limit as x approaches 3, and then square root of x plus 1 times square root of x plus 1 is just going to be x plus 1, and then negative 2 times the positive 2 is going to be minus 4, all over x minus 3. What's 1 minus 4? Oh, man. Yeah, x approaches 3. It's going to be x minus 3 over, hold on. What did I, oh, yeah. Sorry, guys, sorry. Square root of x plus 1 plus 2. I almost messed up. X minus 3. And look, I made a mistake. I didn't put that in parentheses. Square root of x plus 1 plus 2. Well, yeah, but I put it in there immediately. Not left it in there in my paper, and then the next day it was still there. Okay. Are we cool? Yeah, sorry. I didn't mean to throw shade or anything. Sometimes I'm a Terminator. All right, here we go. What can I cancel out? The x minus 3's cancel out. And now can I do direct substitution? Yes. What is 3 plus 1? 4. And 4, the square root of 4? 2. And 2 plus 2? So 1/4. Look at that. Are you shocked? No, the other one was 1/4, so this one needs to be 1/4. How do we feel? All right. So is it getting easier that we're doing a whole bunch? Okay. Here we go. This one wants it at 1. So I'm going to go f prime of 1. Get it up? You're okay? Okay. Making sure, miss. Limit as h approaches 0. I'm going to plug in a 1 plus h wherever I have the variable x. Open parenthesis. 1 plus h, close it, square it, plus 4, in a little bit, we'll go ahead and expand it, minus, I'm going to plug in a 1. What's 1 squared? 1 plus 4. So minus 5, and all this is over h. All right, let's expand it on the next line. So equals limit as h approaches 0. 1 times 1? 1. Plus 1 times h? 1h, but how many do I have? So 2h plus h times h squared, and then plus 4, and then minus 5. All this is over h, and then because I'm trying to show all the work here, one more line. Limit as h approaches 0. I'm going to combine like terms with the first half here. 1 plus 4 is 5. So 5 plus 2h plus h squared minus 5 over h. And I guess technically I could have just combined like terms there and zeroed it out, but I want to show it. Okay, what zeroes out first? The 5s. And now that I've zeroed out the 5s, can I factor out an h? So if you factor out an h, one of those h's cancel. So cancel, cancel, cancel. Only do that if you're a pro. If you're not a pro, go ahead and factor out the h and then delete. What's up?
Could you also
Yes. It's the same. Yeah, because that's -1 and 1, -1, same thing. All right. So now, as h approaches 0, this h right here is going to approach 0. So what do I just have? Just 2. So f prime of 1 is just 2. That's your slope at 1. Your instantaneous slope or tangent slope. Are we okay? All right, let's go to letter B. No, I think that's it. 2x, yeah, 2. All right. Let me change my color to light sky blue. F prime of 1 equals limit as x approaches 1 of f of x, which is x squared plus 4, minus f of 1, which is over x minus 1. 4 minus 5, that is what? So limit as x approaches 1 of x squared minus 1 over x minus 1. At the moment, you can't do anything about it, but you notice that the numerator is the difference of, so I can expand that. So this is going to be limit as x approaches 1, and then the numerator, I'm going to write x plus 1, x minus 1, all over x minus 1. What zeroes out? X minus 1s, and now can I do, or it doesn't zero, I'll cancel out. And now can I do direct substitution? Yes. What is 1 plus 1? 2. So f prime of 1 is equal to 2. So do you see how both of those are the same? Okay. All right. So this one is coming from UH. I believe it's called, I can't remember the quiz name, but I can't remember the quiz number. It might, how many have we done? We did 1, 2, 3, 4, 5. So this might be UH quiz 6. And it's called definition of derivative. Yeah, definition of derivative. So here we go. It says, given f of x is negative x squared plus x, which of the following expressions represent f prime of x? All right, I'm going to go slow. So I'm not even looking at the answer choices. I'm just going to go ahead and go right into it. F prime of x is equal to limit as h approaches 0, because that's the one that we know very well, of f of x plus h minus f of x all over h. All I did was write the definition. Yay or nay? Okay, so here we go. On the next line, I'm going to write limit as h approaches 0, and I'm going to look for my f of x. Here it is. So on the side note, I'm going to go f of x plus h is nothing more than, put a negative there first, open a parenthesis, and then for x, write the expression x plus h, close it, put a square, plus, open another parenthesis, and then for that x, type in x plus h, close it. Do you guys see what I did? All right, what's up, Gian? Ask me. Oh, okay. Let me explain why, miss. So if I were to tell you f of happy face equals negative happy face squared plus happy face. See how I wrote happy faces? So wherever my happy face is, if I put a different expression in for happy face, that's the expression I'm going to put in. So if I write what is f of a plus b, well, now wherever there's a happy face, I'm going to put the expression a plus b. Negative parenthesis a plus b, close it, squared, plus parenthesis a plus b, close it. So that's exactly what I'm doing. It says x plus h, so wherever there's an x, you put the expression x plus h. Did I answer your question? Do you like happy face, or are you a happy face hater? Okay. Sorry, miss. All right, here we go. I'm going to type in what f of x plus h, so I'm going to write negative parenthesis x plus h, close it, squared, plus parenthesis x plus h, close it, minus, and I need to subtract my what? My f of x. What is f of x? I'm going to put parentheses. What's f of x, guys? The negative x squared plus x. Close the parentheses, and all this is over h. Look for something that looks something similar to that. So I'm looking at the expressions. Is it letter A? No. Out of there. Is it letter B? Let's see. Negative, negative, minus. Okay, what is wrong with letter B? It almost looks like it. They tricked you. It doesn't have a limit. Look at the very front. So write that in there for good notes. Right. That's why I tell you the limit thing is important. It does not have a limit. It can't be letter B. Write that in there for good notes. What about letter C? Look, they made them. Maybe they trick you in letter C. Is it letter C? No. Why is it not letter C? It's approaching X. It needs to approach what? Yeah. If you see an H, it needs to approach 0. So letter C's out. So what's the answer? D. They tricked you guys with letter B and C.
That's crazy.
How do we feel? All right. Let's see if you guys can figure out number 9. Take a 30-second head start. What's up, miss?
Can I do it?
No, well, okay. Yeah, go ahead. But first, write the definition
Of what?
of a derivative.
Okay. Hey, girlies. Don't look
Give
up
them,
here.
Give them 30 seconds. Yeah, you do it, and then
Oh.
look up here.
Oh.
She's the next thing.
10:40. No. 3. Just kidding. No. As I'm counting down. 5.
No, go ahead.
Oh, okay.
But you're not gonna look up. You're just.
Y'all can't look up, guys. Do I have better handwriting than Travis, guys? Be honest.
Yeah, I have that.
Oh, wow. Whoa, what's that doing there? I've done this in forever.
Wherever there's an X, just put X plus
I
H.
didn't know what I
I was about to go. No, I was about to.
Me too. I was already.
Yeah, you're not gonna have to do the algebra. Alright, explain it to us.
They're so cute.
Hey squad. So this is the definition of a derivative in terms of limits. Which do they know that? Okay, cool. And this is basically limit as h approaches 0 of f of x plus h minus f of x over h. So f of x is all of this. So I just plug that into that and then add h. And this can't reduce, which is why I kept it as x plus h plus 6 minus 7 over square root of x plus h over h. Do they want us to... Okay. I'll put this in parentheses just to like emphasize it. Is it A? Dang. Is it B?
Why is it not?
Why is it not B?
Good. Pay attention to all the little details.
Is it C?
Why not? It doesn't have a limit.
They actually know
I fixed it.
Is it D? Okay, why is it not D? Yeah, so that's kind of tricky because when you think of like f of x plus h, that was more of like f of x plus h rather than f of x plus h, if that makes sense. Does that make sense? Okay. Is it E? There we go. E's nuts. Okay. Okay, guys, I have to go back to econ.
Yeah, her arrows were nice. Let me see if I can do arrows like that. No,
Start with the line
no.
first.
I can't do it.
And then triangle.
Yeah.
I don't know if I like it.
I don't know.
All right, here we go. Here's another one, guys. So now we're going backwards. Relax, relax.
Don't do this.
We're going backwards. So this is still the definition of a derivative. Look what they want you to find. They want you to find the value. They might as well just call that A, but now they call it C. It says the limit as h approaches 0 of all that represents the derivative of a function f at a number C. Determine f and c. So what they're saying is this. This is f prime of c, which equals limit as h approaches 0 of f of c plus h minus f of c all over h. Why did they switch to c instead of a? They switch all the time. It doesn't matter. Yeah, math textbooks just put random letters all over the place. All right, it's the same concept. So let this one help you out. So check it. Okay, I'm going to go slow. Let this 9 help you out. And notice that the f of x plus h or f of c plus h has a square on it. So that 9, you should already be thinking, well, that came from this. So what number, and look, the square, you're thinking about that square. What number when I square it is 9? 3. And then you notice, look at this. You notice that there's a negative 3 in there. And then you should think to yourself, is negative 3 squared also 9? So more than likely that c is negative 3. It is. Now what is your function? What is the function that gave us that 9? Remember, perfect, you said it. Why is it x squared? Okay, the 9s do cancel out. Okay, but okay. So you got the x squared because you were like, this is an expression, just like all the time we've been doing it. Like, look it over here. This is your expression. And so what De Leon is saying, well, you got that expression, you squared and you got a 9. So that expression must be x squared. Don't worry, if you don't get it, relax. Look, here it is. Look, check it out. Don't worry. Look up here. Don't worry about writing. Let's go, instead of backwards, let's take this information and write the limit expression. If you have this and you want the derivative of negative 3 for this expression, you would have gone limit as h approaches 0, parenthesis, I wanted a negative 3, so you do negative 3 plus h, right? So I'm going to go negative 3 plus h, close it, put a what on it? Squared minus parenthesis, negative 3 squared all over h. And then you're like, oh, is that? Well, yeah, it is. Negative 3 squared is 9, so I'm going to change this to a 9. And then check it out. Isn't that? So then that means my f of x was x squared, and the number that they evaluated at was a negative 3. Does that make sense, guys? All right. So now let's look. What's the answer? A, B, C, D, or E? No, not C, because the C is 9. B. Oh, it is a safe space, miss. Oh, you're in the next one? All right, let's go to number 11. Don't freak out. We haven't talked about trig functions yet. Yes, I think you're right. Yeah, you're right. Good job. All right, so here we go. Look at number 11, guys. Everyone look at number 11. Let this help you out to figure out what that C value is. So this is why we took pre-cal. What do you think my f of x is? Yeah, you got it already. So what's your f of x first? Before is sine of pi over 3 or just sine x? Sine x. What do you think your c value is? Yeah. Now, and this is how you check it. If, in case you're not sure, if you're like, I don't know if I understand this. Okay, let's work our way forward instead of working backwards. If I gave you this and I told you to find f of prime over 3, what would you do? You would do this. Limit as h approaches 0 of sine of pi over 3 plus what? H minus sine of pi over 3. And I know what you're thinking. You're probably like, child, that doesn't look like that. All over h. Okay, hold your horses. Why do people say hold your horses? Hold your pigs, because you would ride a horse and hold your horse. Okay. All right. Check it out. Check it out. What is sine of pi over 3 from your pre-cal days? This is square root of 3 over 2. If you were to rewrite it, look at this. Limit as h approaches, I put him. Limit, because I tried to write h and limit at the same time. Limit a sine of pi over 3 plus h minus square root of 3 over 2 all over h. Isn't this that? So my function must have been sine over x, and the value they're evaluating it at is at pi over 3. Do you guys see that? So you can always let the answers give you the answer. So the correct answer is C as in Charles, or C as in Karina, or C as in Chavez, or C as in Cortez, or C as in Chapas de los Caballos. Okay. Or C as in Chad. Chad Chavez.
Oh, Chad like you.
Chad like me. Cool or not cool?
Like you should say.
Look, this week called you Chad.
All right, we're almost done, guys. I think we can take. Can we take some more or no? Yeah. Okay. Let's take some more. Let's take some more. All right. Yeah. Don't worry. We have a delta as well, but we'll make the delta due like Sunday night. Yeah. All right. I think that's fair. Is that fair? Okay. Here we go. Here we go. Number 12. Given f of 2 equals 3 and f prime of 2 equals 5, find the equation of the tangent line f of x at x equals 2. Okay, let's rewind. Given f of 2 equals 3 and f prime of 2 equals 5, find the equation of the tangent line of f of x at x equals 2. All right. For a tangent line, I need two things. What and what? Do I have a point and do I have a slope? Yes, this f prime of 2 is your slope. That's your tangent slope. It's an instantaneous rate of change. Does that make sense? So for good notes, put that that's your point, and then you put that that's your slope, instantaneous slope at x equals 2. So here we go. Y minus 3 equals the slope. What's the slope? 5 parenthesis x minus 2. You're done. If this were an AP exam and you're prone to accidents, I would tell you to leave it alone. But right now, we're not teaching to the test. Let's go ahead. Well, if you're prone to algebra mistakes, algebra accidents, not like, Okay. So now, let's solve for y equals mx plus b. Y minus 3 equals 5x minus 10. Move the 3 to the other side. Y equals 5x minus 7. No, actually, you'll see when we start taking practice AP exams, some of you, I would say, like there's usually like at least 10%, but it could go as high as 25% of you. Your algebra is just like so bad sometimes. But you know calculus, but your algebra is so bad, and I'll be grading the free response, and I'll be like, you would have gotten credit, but because you kept going and you messed up with your algebra, you lost your credit. So by the time we take the third mock exam, I will know like if your algebra is good or not, and I will tell you like, you know, like you should probably stop. Now, I encourage everyone, because I don't like the phrase teaching to the test. I don't like saying that. So I encourage everyone to be courageous and continue. But if you're just like Chop, yeah. If you're one of those that like Chop, I just want the credit. I just want the credit so I can get it out of the way. Then just stop in a certain location. That way you got the credit and then move on to the next.
I mean, like,
All right.
like the extra work.
No, it has to be. Yeah. All right, here we go, guys. Next one. Find the equation of the normal line. So what's the difference between a tangent and a normal? Opposite reciprocal with the slope. So opposite reciprocal. What's opposite reciprocal of 5? Negative 1/5. So I'm going to write y minus 3 equals negative 1/5 x minus 2. If you're prone to accidents, you can just stop right there. But right now, I want you to be courageous, so go ahead and continue. Y minus 3 equals negative 1/5 x plus 2/5. Job, I don't know how to add fractions without a calculator. Yes, you do. Like this. You see that 3? Turn that 3 with a common denominator of 15, so that's the same thing as 15 over 5. 15 divided by 5 is 3. So what's 15 plus 2? 17. So 17 over 5. There it is. That's my normal. How do we feel? All right. So don't worry, guys. We're almost done. We just got 2 questions left. So let's see what this says. And I'm going to go slow because these are actually simple, but initially you're like, what's going on? So I'm going to go slow. I need everyone's A game. Don't worry. We'll be fine. The graph of the function y equals f of x is shown below is made up of line segments joined end to end. Okay, I can see that. They're all linear lines. Are we okay? Okay. So then it says, so I see a whole bunch of linear lines. It says, at what values of x between -4 and 6 is the function not differentiable? So I don't know if you remember, but I told you you're not differentiable if one of two things happens. Either you're not continuous, like there's a hole, or there's a jump or an infinite discontinuity, or there's an abrupt change, like a corner or a cusp. A cusp is like a corner. I think the way I introduced it to you is like this. If I have a curve and I cannot draw a tangent line at that curve, you're not differentiable. So if I have a curve like this, you're differentiable everywhere because you can draw a tangent line anywhere, see? I can draw a tangent line anywhere. But if I have a curve like this, like let's see, and then, is there a location where I cannot draw a tangent? Yeah, right there. If I'm really close to the left-hand side, my tangent looks like that. Well, like that. If I'm really close to the right-hand side of that point, my tangent looks like that. So right at that point, how does my tangent look? So if you have a corner or a cusp, you do not have a tangent line. And where else are you not differentiable? If your tangent line is a vertical line. But we'll get there when we get to that one. We don't have vertical lines here. Okay. Besides the endpoints, don't worry about the endpoints. Where are you not differentiable? At x equals what? At x equals 0. How am I going to draw the tangent? Is it going to look like this or is it going to look like that? Do you guys see what I'm talking about? So at x equals 0 is 1. So at what values of x between -4 and 6 is a function not differentiable? X equals 0, comma. Where else are you not differentiable? X equals 1, so I'm just going to put comma 1. And there's one more. X equals 4. That's where you're not differentiable because you have corners. It's an abrupt change. And it needs to be a smooth change. You can't have abrupt changes. This is why engines fail all the time. You'll see why. You guys know about engines, like the pistons? Okay, so that piston, yeah, I'm gonna go off on a tangent, and I'm just gonna keep talking. I'm gonna get a real question from engineering. Okay, it says graph the function's derivative. These are all linear lines, guys. So remember, what does a derivative mean? It just means instantaneous rate of change. It just means slope. Yes or no? So all these are linear lines. So that means I can calculate those slopes pretty easy using algebra. So look at this first one here. I have a point at -4, 0. I have a point at 0, 2. So I went up twice and I went to the right 4 times. I went up twice and I went to the right 4 times. What does that reduce to? 1/2. So my slope in this line, my slope is a half. So that's my derivative there. My derivative is a half throughout the whole interval between -4 and 0. Cool or not cool? All right, between 0 and 1, I'm talking about x values. What is the slope of that line? Well, let's see. I went down 1, 2, 3. Wait, 1, 2, 3. 1, 2, 3, 4, sorry. And I went to the right 1 time. So what is that slope? Positive or negative? Negative, because you're going downhill. Are we okay? This is just a horizontal line. It does not change up or down. So it's just a flat line. So my slope there is 0. Let's see, I went from -2 to 2. So I went up 4 times and I went to the right twice. So the slope there, 4 over 2, which equals 2. Oh, yeah, rise over run. Yeah, you're good, miss. Does everyone know how I got those values? Okay, so it says graph the function's derivative. So here's what I'm going to do. I'm going to put a grid. I don't like my grids. Okay, there we go. I'm going to put a grid, and I'm going to call this y prime. Put a prime on it. Are we okay? Okay, at your endpoints, put open circles. Notice that this slope is a half. So I'm going to say that a half, I'm going to say this is 1. So a half is in the middle. So I'm going to say here's -4. And I'm going to say here's 0, obviously. So go to 1/2, open circle. Open circle. So it's just flat. 1/2 all the time. Are we okay with that? Okay, Espinosa asks, tell me, dime. Okay. Okay. So check it out, Espinosa. My slope between 0 and 1 is what? Yeah, -4. So if I'm gonna plot that in here, notice this is y prime. That means slope. I'm going to go to -4. I'm going to say -4 is right here. And I'm just going to plot a point between, I'm going to say that's 1. So open circle, connect those circles. It's -4 between 0 and 1. Oh, because it told me. It says graph. Yeah, it told me right here. Look, graph the function's derivative. They want a graph. And I know that derivative means slope. So I'm just plotting the slopes. No, these are your y's. I'm graphing the derivatives of this function. The derivatives of this function. Which are I'm just plotting the slopes of that function. All right. Sorry, I wasn't trying to be a comedian. I apologize, Espinosa. All right. Well, yeah, I wasn't trying to, but okay. Between 1 and 4, my slope is always what? 0. So it's just going to plot it right on the x-axis. Because remember, you're plotting the derivatives. These are just derivative values. And then I'm going to say that 6 is over here. It's not drawn to scale, guys. Oh. I'm going to say 6 is right there. Okay. What is my slope between 4 and 6? So I'm going to say this is 2, and I'm going to put an open hole here at 4, open hole at 6, and connect them. And there it is. That's how my derivative values look for that graph. Are we okay? Okay, no. It's actually very simple. It's just going to take some time initially. All right. This was actually a AP question, not this exact one, but it only happened once. I think it's in the 80s. I'll see if I can find that free response question. Your parents probably took it. I don't know. I wasn't alive. I was alive, but I was a little kid in elementary school. 83, 84, 85, 86, 87, 88, 89. Oh yeah, 1, 2, 3, 4, 5, 6. I was like in kinder. Okay. Anyways, let's do this. All right, here we go. You guys ready? I'm going to draw a grid. So draw a grid. Okay. Are we okay with the grid? All right. It's a sketch graph of a continuous function f with, notice, all right guys, focus. So it says 0, -1. That's my point. That's my first point. So go to 0, -1 and put a point there. 0, -1 point. Are we okay? All right. Now, what am I graphing? I'm graphing f. So this is f. This is my graph of f. What do they give me? Yeah, what is that 1? It says f prime. What is that? What is that? Is it your mom? It's a derivative, which means what, Espinosa? Yeah, what does derivative mean? Yeah, give me all the definitions you know. The slope of what? Of our f graph. Yeah. It's the slope of a tangent. Are we cool? Yes. Now look what it says. It's a constant 1 for x less than -1. And it's to the right of -1. So I'm going to show -1. This is not a vertical asymptote. And I'm just putting a dashed line. To the left of that dashed line, I better have a slope of 1. And to the right of that dashed line, I better have a slope of -2. So here's how you do it. And I know at first it's hard, guys, because it's brand new to you guys. You haven't done it. But the more you do this, the easier it gets. That point that they gave me, is it to the left or to the right of that dashed line? To the right. I better have a slope of -2. Does that make sense? So I'm going to have a slope of -2 until I hit that dashed line. So remember, that point was 0, -1. So I'm going to go up 2 and to the left once. So I'm going to go up 2, 1, 2, and to the left once. Oh, I'm already there. I went up 2 and to the left once. So that point is -1, comma 1. Because I went up 2 to the left once. Do you guys see that? So then I connect those two. And I want a slope of -2, so there it is. I'm going downhill. Do you see how this slope is -2 to the right of -1? Okay. Now, to the left of that dashed line, I want the slope to be what? 1. So I'm going to take a different color. I need my slope to be a 1. So I need to be going uphill left to right. So I know you're kind of going backwards. So at that point, negative 1, 1, I'm going to go down 1, and I'm going to go to the left 1. So I need to go uphill. So down 1, I'm on the y-axis. I'm on the x-axis. And to the left 1. I am at point negative 2, 0. There it is. It should be a flatter line than the other one. And there it is. That's a slope of 1. The other one is a slope of negative 2, which is steeper. I know. At first it is hard, guys. But it does get easier the more you do this. Now, I had planned an activity with this. But it looks like we're running a little bit behind.